All right, this is the last section in Unit 14. We're going to talk about something called residuals. So I've got residuals filled in here for the I can statement. I can understand and use residuals. So the warm-up starts with a question about the vocabulary word of the day. It says, what does the word residual mean? Now, you've probably heard the word residual somewhere before. Residual usually means something is left over. So left over, okay? Or I'm going to write this. I'm going to write remaining. Now, when I was a kid and I would do the dishes, my dad would say there's some residual food on there or there's some residual dishwashing soap on there. It used to drive me nuts, but what he meant by residual, and I was a little kid at the time, wasn't quite sure, but I could figure it out. It just means that there's something left over there. So on part B, it says, which line do you feel best fits the data? Give at least one reason for your answer. Now, if you take a look at this, we've got a scatter plot here with a line graphed through it and a scatter plot here with a line graphed through it. We have R values. We have correlation coefficients for each one of them. They're both negative because these lines are going down, and they're fairly strong. They're pretty big. They're close to -1 because these points are pretty tightly packed around that line, and same here. In fact, these are really tightly packed together, but I want you to take a look at the way these are tightly packed together versus the way these are. This looks a little bit worse, but here's the deal. These are kind of randomly scattered on either side. There's some above, some below, some above, some below, all the way through here. But if you take a look at this, we'll notice a pattern. This actually, they're all on one side of the line here, kind of below the line here. Then they're all above, and then they're all below. So even though they have the same correlation coefficient, I would probably feel a little bit better saying this one right here because they're randomly scattered about this. This one looks more like a curve. Okay, so I'm going to say random scatter above and below. And then over here, I'm going to say this looks like a curved pattern, not a linear pattern. Now, remember, regression equations, they are really, really useful, and they're pretty easy to use, especially when a calculator or a computer produces them, because we get to avoid all the tedious math behind creating that model. But the calculator can't actually see what the line or the scatter plot look like. And looking at that plot and looking at that line might help us figure out what type of regression model that we ought to use. Now, like we've said before, we're going to stick with linear models, but we want to be aware of when they might have some issues and some things that we need to look for. Now, there's another really helpful tool that can tell us what model best fits our data. It's called a residual. Just like the vocabulary word up above there. And what it does is it helps us determine how far each one of the data points are from the line. So a formula for the residual is it's the observed data value minus the predicted data value, so observed minus predicted. Or if we put this another way, it would be something like this. The residual is the y value of the data. So we actually take the data and then we subtract the y value of the line that would correspond to that. Now, I've got a little picture here. Hopefully this will help kind of describe what residuals are and why we might be interested in them. So I've got a linear regression equation right here, this blue line right here, and then I've got some data points. We've got 5 data points on this particular scatter plot. And I've picked one right here. This data point has a positive residual. Now let's look at this positive residual. It says the data is above or below the line. Well, the data point is actually above the line. So for a positive residual, the data point is always going to be above the line. And that makes the line, which would it be, an over or an underestimate? So the actual data point, the observed data point is right here, and the predicted value would be down here. So the prediction is underneath the data point. So this makes it an underestimate. So if the data point is above the line, then the line is actually an underestimate. And let's take a look at this negative residual situation right here. The negative residual means that it's below the line, so kind of the opposite right there. And that makes the line would be above it, that makes it an overestimate. Okay, so it's kind of the opposite relationship here. Now, we already know how to make scatter plots and find regression equations and models and stuff like that. But plotting the residuals, it can actually help us more easily tell what the pattern is, and it helps us make better decisions. So we're going to start with a really familiar example. So I'm going to slide down here and we're going to take a look at this example. I'll let you take a look at that for just a minute. There's a whole bunch of stuff going on here, and this is what it takes in order to calculate residuals. Don't worry, it's not nearly as bad as it looks. But this is the coffee cooling data. Remember, it started off at 0 minutes, right when we start the stop stopwatch at 186 degrees, and then it slowly cools down. Now, I've taken the liberty of writing down the linear regression model. So remember, it's negative 2.41x and then plus 180.13. And the correlation coefficient for that was negative 0.98. It was a very strong correlation. So we're in good shape there. Now, what we're going to do is we're going to fill out the table here, and I'm going to help you do some things on the calculator that you may not have seen before. We're going to use vars, y-vars, and then we're going to use y1 function in order to make some of these predictions. It's going to make it a lot easier than doing all this stuff by hand. So let me show you what's going on here. This is the X value, the time in minutes. This is the actual temperature of the coffee, 186 degrees. And the predicted line temperature, the predicted temperature on the line is 180.13. And the way we get that is if you plug in a 0 right here. So if you plug the X value into the line, you get 180.13, because if you plug a 0 in here, that would go away and you just get 180.13. Now, in order to find what the residual is, we take the data value and we subtract the line value. So this is the observed value and this is the predicted value, or it's the y value of the data minus the y value of the line. So we get 5.87. Now, just for the heck of it, I'm going to pull up the calculator and we're going to do that calculation really quickly. We're going to do 186. So I'll pull this up here, turn this on, 186. That's the actual data value, the observed data value, minus 180.13, and we get this right here. We get 5.87. So probably the easiest thing to do is to just go ahead and fill these in right here. Now, I'm going to show you this one. So if we were to plug in a 1, we put a 1 right there, and then we figure out what the projected or predicted data value is. So I'm going to do this one by hand, and then I'm going to show you an easier way to do it. So we're going to do negative 2.41, and then we're going to times that by, that was 1 minute, remember? So 1 minute right here. So we're going to times that by 1 minute. And then we're going to add the 180.13. So make sure we type that in there the right way. 177.72. And then we just do a little subtraction problem. We're going to do the 179 minus the 177. So I'm going to do 179 minus 177.72. And we end up with 1.28. So I'll do 1.28 right here. So we filled in our first blank there. Now, here's what I'm going to do on the calculator. I'm going to shrink this down so we can see this a little bit better. And I'm going to show you how to use this vars and y-vars. So I'm going to clear this off, and we're going to put this into the y equals menu. So we're going to go back to y equals, and we're going to put in negative 2.41, and then we're going to times that by x, and then we're going to add 180.13. Okay, so we've got negative 2.41x, we've got 180.13, all set to go there. Now, I'm going to go back to the home screen and I'm going to show you this calculation a different way. So I'm going to hit the vars button. So vars is right there and right here on the calculator. So I'm going to hit vars. Then we're going to do y-vars. So we're going to come over to this second one, and then we're going to hit number 1, which is function. So we're going to hit this. Now notice what this does. This gives us a list of all of those the functions in the y equals menu. Now we just put that in y1, so I'm going to hit enter and grab y1. It's going to go back to the home screen. And the cool thing about this is this works just like function notation. So I'm going to put a set of parentheses. I'm going to put a 0 because I'm going to kind of predict this first one again. And I'm going to hit enter, and look, it says 180.13. So what we're going to do is we're going to keep going and we're going to fill this out right here. So I'm going to put in the 1. So I'm going to do, again, it's vars, y-vars, function, hit number 1, and then I'm going to put a 1 in there because we're plugging in a 1. This is just like function notation. This is y1 of 0. This is y1 of 1. We hit enter, and there's the 177.72. Now, rather than typing that in every single time, I can do something that's really clever. You know how to work with deep recall, so we're going to hit second and enter. It's going to recall that last command, and now all I need to do is I just need to change that to a 2. So I'm going to put a 2 right there, and I get 175.31. So over here, I'm going to type 175.31, and we're just going to continue doing this. Now I'm going to show you one other thing that can be helpful. I'm going to hit second enter. It's not absolutely required that you put a set of parentheses to close that. Any end parentheses can be left off the calculator most of the time, and it doesn't have any impact on the answer. So this actually makes things slightly quicker, saves us a couple button clicks. So I'm going to hit second enter. That recalls that, and I'm on number 3. So I'm going to plug in a number 3 for 3 minutes. So at 3 minutes, this is predicting that the coffee is 172.9 degrees, so 172.9 degrees. At 8 minutes, let's just double check here. So I'm going to hit second enter, make that an 8. Hit enter, 160.85, we've got that one. Now we're going to predict the temperature for 13, so we just type in a 13. I've got 148.8, 148.8. And then, again, I think we're in good shape here. I think we know we've got this right, but let's just go ahead for the heck of it. There's 136.75, and then the very last one is going to be 23. Now, I realize this is a little bit tedious, but can you imagine typing in all of these from scratch on your own? So 124.7, okay? Now all we have to do is just do each one of these subtraction problems. So the next one I'm on is this one right here, so 171. So I'll do 171 minus, what do we got here? 172.9, 172.9. Again, always a good idea to make sure that you've typed things in the right way. So this is negative 1.9. We'll skip down here. We've got 137 minus 136.75. Got that in the right way. So this is going to be 0.25. And then we've got 129 minus 124.7. And got that in right. So we've got 4.3. Okay. Now, we've got basically what we need from this. So I'm going to get rid of the calculator and we're going to go full screen on this. So here's what we notice about this. You'll notice that we've got some fairly large values right here and they're positive. Then we've got a bunch of negative values and then some positive values. Again, I'm going to make that look like a decimal again. Okay, so these are the residuals. Now what we want to do is we actually want to plot the residuals against the x values. So we're going to plot this as x and we're going to plot this as y. Now, you'll notice that in the y direction, we really don't need to be any bigger than positive 6 and any smaller than, let's see, negative 4.8. So here's what I'm going to do. I'm going to do 5 on this, and I'm going to do negative 5 on this, and then we'll put 0 right there. If you want to put the, label the tick marks in between, that's totally okay with me. So for 0, we're just plotting the residuals. We basically get to ignore this stuff right here. We're not really interested in any of this right here. All we're interested in is what is the pattern in the residuals? What are the pattern in what's left over from what we predicted the values would be? And we've got these calculations right here. So with the vertical axis scaled, I've got to make sure that I scale the horizontal axis, and we need to fit all of these values in right here. So we need to fit in from 0 all the way to 23. Well, we certainly can't go by 1, but what I could do is I could say this is 5, this is 10, this is 15, this is 20, and this is 25. That'll be enough to fit everything on there. So I'm going to come back here, and let's go ahead and start plotting these. So remember, this is going to be the x, and this is going to be the y. So I'm going to plot 0. At 0, the residual is 5.87, so a little bit less than 6. So maybe about right here, okay? And then at 1 minute, it's about 1.28. Well, 1 minute would be about right here, and 1.28 maybe about there. At 2 minutes, let's see, we've got negative 0.31, so maybe about right there. At 3 minutes, it's negative 1.9, so 3 minutes, 1.9 would be about right there. Okay, so 3 minutes, 1, 2, 3, 4, 5. 3 minutes would be about right there. That looks pretty good. And then at 8 minutes, it's negative 4.85. So 8 minutes would be about right here. So negative 4.85. So about like that. At 13 minutes, it's negative 4.8. So 13 would be over here. And just barely higher than that one. So it looks something like that. And then at 18 minutes, we're at 0.25. So 18 minutes would be this right here. Okay, just barely above that. And then at 23 minutes, we're at 4.3. So 23 minutes and 4.3 would be about like this. Okay, now, when we're looking at a residual plot like this, so this is what this is called. We're going to call this a residual plot. When we're looking at this, randomness is a good thing, okay? Pattern in residuals are not what we want. So you'll notice that we can see a very clear pattern. It looks like we've got some points above, getting closer, then below, way below, and then back above. This is a very clear pattern. And when you see a clear pattern in a residual plot, that means that our model is, there's something else going on that we probably ought to be aware of. So what we're going to do next is we're going to draw the scatter plot and the line of best fit for the coffee data, and we're going to see if we can kind of tell what's going on just by looking at that. So I'm going to bring that up again. I'm going to turn this on, and I'm going to go to y equals. I've got the data in there, so that's good. I need to turn the plot on. So the plot, I need to turn that one on. And it's a scatter plot, and we're all set to go. I need to make sure that I've got a decent window. So we're going to go from 0 to 29, 0 to 25. Yep, that would work. And then the temperatures for this data, the lowest that we get is 129, so that should fit just fine right there. So let's go ahead and graph this, and let's see if we can tell what's going on. So I'm going to hit graph, and we've got our scatter plot, and then we've got that linear regression equation. So here's what I'd like you to notice. On that very first one, that first data point, we've got a positive residual. So I want you to look where it is. A positive residual means the point's going to be above the line. And then the next one, at 1, it is just barely above the line. And then for 2, which would be right here, it's almost on the line, almost exactly the same. And then notice what happens. We go from points that are above, because they've got positive residuals. We've got a whole bunch of points that are below. There are all the points that are below. And then we've got a couple that are above again. Okay, so these last 2 are above. So this kind of curving pattern around the line, where they go from above to below to above, you can see very clearly on the residual plot. We're above the line, we're below the line, and then we're above the line. Positive residuals, negative residuals, and then some positive residuals again. Okay, so if we've drawn that, we notice that there's a curve on both of those. Okay, so we're going to go ahead and write, once I get this to be full screen, we're going to go ahead and write what we notice about this. Okay, so what we'll notice is that the points curve around the line. And we'll say not random scatter. And that's what we want. We want random scatter about that scatter plot. Okay, kind of a good name for it. Now, if I slide down here and we take a look at example number 2, so we're looking at these residual plots, and I'm going to underline residual plot right there, and it says, what do they suggest that we should be aware of? Well, the first thing is this line right here. Remember, on a residual plot, that line is 0, so I'm going to put a 0 on each one of those. Okay, this represents 0, and then anything up here is a positive residual, meaning the points above the line, and anything down here is a negative residual, meaning the points below the line on the actual scatter plot. So if you'll notice this right here, we kind of see above and below, just kind of all over the place, kind of evenly all the way throughout. If we look at this one, we see above and below, above and below, above and below. So that one's not too bad. But this one, we definitely see this curved pattern. Okay, so there's got to be something else going on. But let's take a little bit closer look here. This one, again, they're scattered above and below, and they're scattered above and below the same way all the way throughout the same thing. So we're going to say, what should we be aware of? Nothing. Okay, pretty good model. So this is going to be a pretty good model. Now, if we take a look at this one, this is still a pretty good model, but you'll notice that it's a really good model here, and then they get further and further away from the line, further above and further below the line. Okay, so model gets worse as the numbers get bigger. Okay, so we're going to write model is worse when x gets big. Whoops, just big, 1G there, okay? Model gets worse as x gets big. So it's a good model here, so we'll say good here, and then we'll say not so good here, okay? All right, and then the last one, we want to take a look at that one, and you'll notice that there's this curved pattern like we had before. If we've got a curved pattern, that suggests that this is probably not a linear type of pattern. We probably ought to use something else. So we'll say not a linear scatter plot. Not a linear scatter plot. It's going to be some sort of curve of some type. Okay? All right, so hopefully that gives you the introduction there. We were already familiar with what this scatter plot and this data looked like. We're going to take a look at another one on the other side that we have not seen before. So let's go ahead and look at that. Okay, so I'm on the second page, and there's something really important that we want to look at here. We haven't seen this before, but this is a really cool thing that the calculator does. So it says hit second and stat to access the list menu. And if we've done a regression since the last time the calculator was reset, there's going to be a list in there called resid, and that's for residuals. Okay, and this happens automatically every time you do a regression. So I'm going to come back here to the calculator that we did a regression on before. So I'm going to turn this on, and I'm going to pull it up, and I'm going to take a look at this. So again, the instructions on this said we're going to hit second, which is right here, and then stat to access the lists. Now, on most calculators, it has all 6 of the original lists that we have in there by default, L1 through L6, and then number 7 is usually the residual. Now, if you reset your calculator, the only things that are going to show up in here are L1 through L6, and sometimes there won't be anything at all. So this happens on every TI calculator, so we've got this residual right here. So again, that happens automatically. So we're going to come back here and we're going to take a look at example number 3. And we're going to do this from scratch. So it says, let's examine the speed and stopping distance using a linear regression and residuals on the calculator. So we're going to do both here. And this information comes from a place called nacto.org. All right, so in L1, we're going to put the speed data. In L2, we're going to put the stopping data. And what you'll notice is, if you're going fairly slow, it doesn't take very long to stop. But if you're going really fast, it takes a really long time to stop. And what we want to do is we want to figure out, gosh, could we use a linear regression model in order to make predictions about, hey, if you're going this fast, it's going to take you roughly this long to stop. So I'm going to pull up the calculator right here, and I've got the 84 on this one. So I'm going to shrink down the size of this just a tad. So here's what we're going to look at. So I've got it on. I'm going to hit the stat and edit. I've taken the liberty of putting all of this information in here, and I double checked before we got started. So I'm all set to go. So we've got the data entered. If you want to take a minute to follow along and pause the video so you can put the data in your calculator, that would be fine. And we're going to find a linear regression model. So I'm going to hit second quit. I'm going to hit stat again. I'm going to hit calculate, and we're going to do a linear regression. So I'm going to hit number 4. Again, it's got L1 and L2, which is where the data is. So I'm just going to hit enter. Several times I'm going to get down to calculate, and I'm going to hit enter right there. So there's our linear regression equation. So it says, find the regression model, record the R value, and look at the line and the scatter plot. No need to write the equation or draw the plot. So let's write down what the R value is. The R value is basically 0.99. Okay, so it's 0.988. So we're going to do 0.99. There's our value there. So this looks like it's pretty darn good. Now we want to look at the line and the scatter plot on there. So I am going to go ahead and write this down so I can get it in there. Or we could do this. Let me show you how to do this really quickly. I'm going to go back here to linear regression. Okay, so I'm going to hit stat and then calculate. I'm going to hit 4 for linear regression. And then if you come down here, it says store this regression equation. Well, if you want to store it somewhere, you want to store it in the y equals menu. So remember that whole vars thing? So we're going to hit vars, y vars, function, and y1. So what this is going to do is it's going to store that in y1. We're going to come down here and we're going to calculate. So notice we get the same answers that we did before, but we get a little advantage here. We're going to hit y equals and look at this. It's already got that value in there. Now, this looks really ugly. If you want to leave it for all the decimal accuracy, you're totally welcome to. I'm going to change that to a, let's see, 0.966. So I'm going to change that to a 7, and we're going to delete everything else. It's got quite a bit of decimal accuracy in here, as you can see. It's got like 10 or 12 decimal places. And then one, minus or plus that, I'm going to, we'll just leave it, okay? It's doing a plus, a negative. I usually just like writing a minus, okay, but we'll go ahead and leave that. And then we're going to have 87.33, so I'll go ahead and delete that. Again, there wouldn't be a problem with keeping that decimal accuracy on here. We're kind of in a habit of just doing it to 2 decimal places, so we're in good shape there. Now, I'm going to go ahead and make the scatter plot, so I'm going to hit second plot. We're going to turn that on. We've got L1, L2, so we're all set to go. Let's check the window. I took the liberty of entering some values in here. The X values, so again, these are the X's that we'd be interested in, these are the Y's. They go from 10 up to 90, so I went from 0 to 100 just to give a little bit of a cushion on each side. The scale I'm going to do every 10, so I missed that one there. And then the stopping distance, we've got a fairly small value of 27 all the way up to 584. So I'm going to go from 0 to 600, and we're going to put a tick mark about every 50. Now, all we want to do is we just want to look at this. So we're going to hit graph. All right, so there's our line, and there is our scatter plot. Now, if you've got a keen eye and we're listening to what we talked about before, you'll notice that these are above, those are all below, and then those are above. So now that you've seen the scatter plot and know the R value, what do they suggest about the fit of the linear model? So the R value is pretty good, but now that we've looked at the scatter plot, we're going to say something like, it's a pretty good fit, okay? But I'm going to put an asterisk by this. Might want to look at residuals, okay? Because of this pattern of being above and below, I mean, it's really not too bad. It's doing a pretty good prediction right here. It looks like it's following right along with the data, okay? But we might want to look at the residuals and maybe consider something else. Now, like I said before, we're only studying linear models basically in this class, so we're going to stick with the linear model. So here's what we're going to do. It says copy the residuals, the resid list, into L3 from the home screen by pressing second and then stat to access the list menu. So here's what we're going to do. We're going to go back here, and remember, if I hit second and stat, it's got that residual list in there. So I'm going to do this from the home screen. There's a couple different ways to do this. So we're going to do this the residual list into L3. So we do this by hitting second. Okay, so I'm on the home screen. I've cleared everything off. I'm going to hit second and stat for the lists. I'm going to grab the name of number 7. So I can go down there, or I literally can just hit number 7. That puts that on the home screen, and then we're going to press the store button. So the store button is right here next to the 1, and then we want to store it in L3. Remember, L3 is above the 3, so we hit second and L3. So if I hit that, now it gives me this set bracket and a whole bunch of ugly things. So we're going to come back here, and we're going to go to the stat, and we're going to go to edit, and you'll notice that all of those are in there now. Okay, now there is another way to do this that might be a little bit quicker, and I showed you how to do that before. So I'm going to do this right here. You can see that we've got the residuals in there, but I'm going to go like this. I'm going to say, hey, I'm on L3, and I want to make this the residuals. So I'm just going to hit second and list. I'm going to grab the name residual by hitting number 7. And then down here, like I showed you before, it says L3 equals the residual list. Now watch what happens, because we already have this list in here. When I hit enter, it should look exactly the same, and it does. Okay, so we're all set to go. So we've got that copied in there. Now we want to create a scatter plot using L1 and L3, and zoom 9 can be really helpful. So here's what we're going to do. Okay, we're going to go back to the stat plot. We've got that one on, but this time, instead of doing a scatter plot of the original data, the speed and the stopping distance, we're going to do a scatter plot using the speed for the X list and the residual for the next one. Now, we could just recall the name of residual. We could do to second and list and stuff like that, but I'm going to say L3 right here. Tends to be a little bit quicker, not much. Okay, and then I'm going to hit zoom 9. Zoom 9 is zoom stat. So if I hit zoom, second quit. There we go. Okay, I'm going to make sure that we've got it on here. Yep, L1, L3, so we're in good shape there. So I'm going to hit second quit. I'm going to hit the zoom button. And if I come down here or up here, okay, and down probably would have worked a little bit better. If you take a look at number 9 is zoom stat. Now, what zoom stat does is it considers what you want to graph, and it says, hey, I'll create a nice window for this. Now, it's not uncommon to get an error when you do something like this. So I want to show you what happens here really quickly if I just blindly hit zoom stat. So I'm going to go ahead and hit that. Now, I get a decent window, but remember, this is that line that we had before. If we're looking at a scatter plot, we really don't want to see the line. So I'm going to go back to y equals. Okay, I'm going to turn that off. And then I'm going to hit graph again. Now, if you're trying to graph a line and a scatter plot at the same time and they don't match up at all, it's going to give you an error. This one, you can actually see one of them, so we were in good shape. So if you ever get an error when you're trying to graph and you're thinking, what's going on here? A lot of the times it's because a stat plot is on, and you can just go ahead and turn that off just by toggling it off. So I'm going to go ahead and hit graph again, and then it says create the scatter plot, and then it says use trace and arrow keys to copy the scatter plot here. So we're going to come here and we're going to hit trace. And the first one is 10 and 44, about 45. But notice this first tick mark is 10. So let me see what I've got here. We've got 10, 20. So let's go ahead and mark down 20, and then 40, and then 60, and then 80, and then 100. So we've got those on there. And then we've got to be, that's about the biggest it gets. So this has got to be 44. And we get fairly small there. So let's just count these by 10. So let's go, this would be 20, and then this would be 40, and then this would be negative 20, and this would be negative 40. And remember that center line, like we said before, center line on a residual plot is always going to be 0. So we're going to do 10 and 44. So we're going to go about right there. Okay, it doesn't have to be perfect. Hit the next one, 20 and 11. 20 and 11 would be about right there. Next one is 30 and negative 12-ish, so around there. Next one is 40 and negative 27. 40 and negative 27, so about right there. Maybe a little lower than that one. Okay. Let's see, the next one is 50 and negative 32. So 50 and negative 32, somewhere around right there. And then 60 and about 26-ish, 27, 60 and maybe about right there, because that other one was 27-ish if I remember correctly. And then 70 is negative 12, so around right there. And then 80 is 11, so we're about right there. And 90 is the last one, 90 and 44. Now wait just a minute, this one was 44.6. This one for 90 is 44.3, so we're about in the same place. So notice our residual plot looks a heck of a lot like this right here. So what do we notice about the residual plot? It's curved. Okay, definite pattern. Definite pattern, not a random scatter like we would normally see. So it says, what type of regression may fit better? Now, if we see that the original one was curved, or we see a curve in this, it may be an exponential. So I'm going to put an exponential one, okay, because that's the one that we know. Let's come back here and let's try an exponential one and see what we've got here. So I'm going to go back to the home screen. I'll clear everything off just because that's a good place to start. I'm going to make sure I've got my bearings by saying, okay, the data is still in L1 and L2. Okay, so let's go back and take a look, and let's hit second quit. Let's hit stat and calculate, and we want to do an exponential regression because that's got the capability of having a curve to it. So we're going to hit enter. Let's see, we're in good shape there. I'm just going to hit L1, L2, yep. If you want to put the regression equation in there, that would be just fine. I'm going to just hit calculate. It's going to do that. Now notice what it says. It gives us a regression equation, but take a look at the R value. The R value, the correlation coefficient, is 0.97. So even though this was a curved scatter plot, there was a pattern to it, and if we looked at the scatter plot, there was a bit of a curve to it, the linear regression actually has a larger correlation, a stronger correlation than the other one. Now, here's what I want to point out with this. We have been talking about linear and exponential regressions for quite a while. We know linear and exponential curves and stuff like that. Okay, but here's the deal. They are not the only models that exist. In fact, this particular one that we're looking at here with this breaking data, it's not linear and it's not exponential. It's something else, okay, something that we haven't studied yet. Okay, but we can at least know that there's an issue with this by knowing, hey, there's a pattern, a curved pattern to this residual plot, and there's a curved pattern to the scatter plot. And I did the only curve that we've got so far, and its correlation coefficient was actually smaller than the one for a linear model. Okay, so we know there's something else going on. So this is part of being a good consumer of statistics and data, is knowing when you need to be really careful and when you should be cautious about other things. Okay, so that's what the scatter plots and the correlation coefficients and residual plots, they help us be aware of how well our model works, when we might need to be aware of something else, when we might need to look for something else. And if you study statistics some more, you're going to learn about these more complicated and more advanced modeling methods. So the last thing we're going to look at is we're just going to look at a scatter plot. That's right here. And again, notice that these are scaled, not labeled. We don't need labels on this particular one because it's just some old random scatter plot. And then we've got residuals for each one of these. Now, I want you to notice that one of them you should be able to eliminate right off the bat, and it's this one right here. You'll notice that the 0 line is right here, and this says all of the data is above the line. Okay, that would not work. Okay, so the center line's got to be 0. So we can definitely eliminate this one right here. Now, this first one is below the data, so we should be looking for one to start with a residual that is negative, a negative residual. So let's come over here and take a look at this one. That one is right on 0, so that's not it. That's negative, and that's negative. Okay, so we look good on these two. I'm going to cross that one out. The next one is above the line, so that's going to be a positive residual. So we had a negative residual, then a negative residual, then a positive. So we're looking in pretty good shape so far. And then the next one is a little bit below the mean, so we're looking for a small negative residual. So we were negative, positive, negative. Okay, so that looks pretty good. Negative, positive, and positive. So because that next one has a positive residual, we know we've got to be this one right here. So I'm going to go ahead and circle this, cross that one off, and that is everything that we need to study as far as 2 variable data and statistics. Now we've got a practice test coming up. We realize there's a whole bunch of stuff going on here, and that the explanations take quite a while. Again, statistics and data are something where it takes a long time to talk about them. It's kind of like an English class or something like that. It almost takes more time to explain what's going on than to actually do it. So hopefully you're in good shape. Good luck, and if you've got any questions, please ask.